Okay, here we go, kids. This is lesson number 8, which is going to be the 2016 numbers 5 and 6 of the free response questions. These are non-calculated questions. So let's go ahead and get started. The first question that we have is a picture right here. I believe that we're probably going to be finding an area of some sort with this. What we are asked to do is let R be the region in the first quadrant enclosed by the graphs of the square root of x, so that's the curvy one, and x over 3, or how I like to write it, 1/3 x, is shown in the figure above. What is the area? Okay, that one's pretty easy. That's a straight up integral. So the area, okay, so this is, first and foremost, let me write my name on here. So I don't get it confused. This is 2016 FRQ, numbers 5 and 6. This is number 5A. And then the area. So the area is going to be the integral from 0 to 9 of the top minus the bottom. Alright, so that is going to be our area. So this is x to the 1/2, so that will be to the 3/2 2/3 minus x squared divided by 2, 1/6 in the world of 0 to 9. So I plug in the 9 minus the 0. So the 9 is going to be 2/3 9 to the 3 over 2 minus 1/6. 9 squared minus 0, but 0 is 0, so I'm not going to worry about that. Okay, so here we go. 9, square root of 9 is 3. 3 to the 3rd is 27. 27 divided by 3 is 9. 9 times 2 is 18. Minus 9 squared is 81. 81 divided by 6. They have a common 3, so that would be 27 over 2. I'm not good at fractions without a calculator, so this is 36 minus 27. And so that comes out to be 9 over 2. I'd probably advise you use a calculator. I know this is a non-calculator question. However, they say that you can use a calculator on this year's version. So I would probably go ahead and use a calculator, just to ensure your math is correct. All right, that's question A. Question B. Write but do not evaluate an expression. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid generated when r is revolved around the horizontal line y is equal to 4. Alright, kind of taking our picture into consideration. Alright, so we see that we have a square root and we have a line of 1/3 intersecting at the point 9, 3. Okay, so that's the square root. This is the 1/3. Now, notice that y is equal to 4 is above both of those. Okay, this is your axes of revolution. So it's still dx, okay, still integrating up and down, still dx. However, the big radius is going to be the line, the small radius is going to be the square root. So here we go. So volume is going to be pi integral from 0 to 9 of the big radius, which is the 1/3 x, okay, minus the new axes squared minus the little radius minus the new axes squared. Right, but do not evaluate. There you go. That's your volume. Okay. That is right, but do not evaluate. Okay, now C. I'm going to have enough room here. Here we go. The maximum distance between the graph G. G is the square root. G is the square root. The maximum distance between G and H. H is the 1/3 x. Between 0 and 16. Okay. So the distance in general, okay, whether it be positive or negative, is, for instance, the square root of x minus 1/3 x. Now, the negative is the same thing as the positive. We'll take care of that a little bit later. So, how do you maximize or minimize important things? Well, you take a derivative of that, of course. So, what is, I'll call this a difference, d, big D. So, big D dx, and so that is going to be 1/2 x negative 1/2 minus 1/3, or in other words, 2 square root x minus 1/3. Multiply that side by 3, multiply 2. So this is going to be 3 minus 2 square root x over 6 square root x. Okay, so that's the derivative. Now, how does that help you maximize or minimize stuff? Well, you take that equal to 0, or where they're undefined. Where is there undefined and things like that. So I see that I have an undefined when x is equal to 0. Okay? So I'll take that. But now I kind of need to figure out what is the actual 0 of that numerator. So what I'm looking at is, where is 3 minus 2 square root x equal to 0? Alright, so I'll add this, divide by 2, and square. Okay, so 9/4 is another important point. So let's take a look. And so again, this is on the world from 0 to 16. So all important pieces between 0 and 16. Okay, we have an x of 0 itself. We have an x of this 9/4. And we also have an x of 16. Alright, so what is the distance between the two things at those things? So square root of 0 minus 0 is 0. At 9/4, that would be square root minus 1/3, or aka 6. So 6/4 minus 3/4 is 3/4. Okay, so that comes out to be 3/4. And at 16, this would be 4 minus 16 over 3. This is 12 over 3. So 12, that'd be negative 4/3. Alright, so as I said, a distance between two things, it doesn't matter if it's positive or negative. So, like, the actual distance is 0, 3/4, and 4/3. Alright, so the question still persists. What is the maximum distance? What is the maximum vertical distance? Well, that maximum vertical distance would be 4/3. And that would occur when x is equal to 16. Boom. Okay. On to problem number 6. Set that aside. Problem number 6. Okay, let g of x be equal to 4 quantity of x plus 1 to the negative 2/3. F be defined by that integral. What is f of 26? So let's just plug and chug. F of 26 would be 0 to 26 of g of t dt. So that would be 0 to 26 of g of t. So that's 4t plus 1 to the negative 2/3 dt. Okay, again, when I have like something that resembles a chain rule, it always kind of makes me weary. Now I know this one will work out just fine, but just when I have these chain rule problems, I like to do use substitution. I don't know, I think it's just me and my weirdness, but I really like to do use substitution when it comes to something that resembles a chain rule. Alright, so my u in this case is going to be t plus 1. du would be 1. Okay, I need that number, that coefficient, to be a 4, so that implies that I'm going to have to multiply by 4 to get there. But because it's a definite integral, I have to reevaluate my limits, so you plug it into the regular u, so 26 plus 1, and the 0 becomes 1. So that changes this to 4 integral from 1 to 27 of u to the negative 2/3. Alright, so here we go. Increase by 1, flip it, so that's a straight up 3. There's a 4 already out there, and this is being evaluated from 1 to 27. Okay, this is a third root, so third root of 27 is 3 minus third root of 1 is 1. That's 2, so this is 24. Boom. Okay. Determine the concavity of the graph of y is equal to f of x. Okay, for x is bigger than 0, justify your answer. Alright, so let's talk about concavity here just real quick. So concavity. Okay, there's two different ways that, in essence, you can tell concavity. So if I'm talking about the concavity of f, that indicates, if I take the derivative, where is it increasing slash decreasing. Okay, that will tell concavity. Another way to tell concavity is where the second derivative is positive or negative. That's another way to tell concavity. So let's kind of start heading down this road here to talk about concavity. Okay, so if f itself is equal to 0 to x of g of t, okay, that would imply that the derivative, okay, notice how the top is an x, so that x just goes in. So again, that's the second fundamental theorem of calculus. Alright, so that would imply that the second derivative is g prime of x. G prime of x. Okay, so that's the one that I'm going to kind of be working off of. So g is this equation right here. So g prime is going to be drop down the negative 2/3, so that's negative 8/3 minus 1. Chain rule would be times 1. Chain rule is times 1. Alright, so that's really kind of confusing. So what I'm going to do is I'm going to rewrite it so like numerators are numerators, denominators are denominators, things like that. So this is 3. This is the third root of x plus 1 to the 5th. Okay, that 5th can be on the inside or outside, all underneath negative 8. Okay, so what I'm looking at here is the second derivative of f. So I need to know, where is that positive and negative? Okay, so where is this positive and negative? Well, note that x is exclusively bigger than 0. Okay, x is exclusively bigger than 0. So this right here is always going to be bigger than 1. Okay, so what that tells me is this denominator is always, always, always going to be positive, and that numerator is obviously always, always, always going to be negative. So that implies that this is less than 0. Okay, this is less than 0 for all x's that are greater than 0. All right, so let's answer the question. What is the concavity for the x is bigger than 0? So that says f of x is concave down due to f double prime g prime is less than 0 for x greater than 0. That's why. Alright, so that was B. C, right here, let h be the function defined by this. Find the minimum value of h on the interval from 0 to 26. So again, when I'm finding minimums and maximums, you want to look at critical points or where the derivatives are equal to 0, and also the endpoints. That's the candidates test. Alright, so what we probably want to do is figure out what the heck is h prime. So h prime would be 1 minus f prime. And so what we also know from back here, f prime is just straight up g of x. So this is 1 minus g of x. Okay, that was from problem B. So 1 minus g of x being 4x plus 1 to the negative 2/3. Okay, so that's our derivative. Now, where is that thing equal to 0? All right, so I want to know where is this equal to 0. Okay, that will tell me crucial points. So let's just kind of do this simplistically. I'm going to keep the 1 and I'm going to add all this. So 1 is equal to 4x plus 1 to the negative 2/3, divide by 4. That doesn't really make a whole lot of sense to me. Let's say, okay, that's a bottom third root of x squared. So let's flip them. Take it to the third power. Okay, square root. And then minus 1. So when it's positive, that will be 7. When it's negative, it'll be negative 9. So those are your two answers right there. However, we are looking from 0 to 26, so this negative 9 doesn't really count. So it's exclusively 0 to 0 to 26. Okay, so let's go ahead and take a look at this with the possible candidates. So we have an x of 0, that's an endpoint. We have an x of 7, and then we have an x of 26. And we are looking, where is the minimum of h? So let's figure out what is the h of x at all of these things. So h of x is, not that, h of x is this. So h of x is 0 minus f of 0. What does that mean? F of 0 would put this at an integral from 0 to 0. Okay, if this is f of 0, 0 to 0. So that integral is equal to 0. So that's equal to 0. Let's jump down to the 26. So h of x is x minus f of 26. And they did us a huge favor by us doing problem A. So f of 26 is equal to 24. So this is 26 minus 24. This is equal to 2. Alright. Now last but not least is 7. And so this is going to be a little bit more difficult because I need to figure that f of 7 real quick. So let's kind of do some work here. Let's figure out what the deuce f of 7 is. F of 7 is, going back to our equation right here, would be the integral from 0 to 7 of g of t. So again, what that implies is this would be the integral from 4x plus 1 negative 2/3 dx, or t. Alright, again, I don't feel comfortable, so I'm going to make my adjustment. So this is the same thing as saying the integral from 1 to 8 of u to the negative 2/3. Increase by 1, flip it, 1 to 8. So this is 12 of third root of 8, third root of 1. So that's equal to 12. So alright, so that just figured out the g of 7, so this is going to be 7 minus 12, this is equal to negative 5. So the question persists. The question is, what is the minimum value of h? The minimum value is negative 5. And it's obvious that we use the candidates test to figure that out. And that's it. That is the ball game right there. Again, what I would probably do before I cam scanner all this stuff is, one, put my name on all of it. Like your name, not my as a teacher name, but put your personal name, and this is 1 of 3, this is 2 of 3, this is 3 of 3. So what I would do is I would scan these things and send them in. Yeah, don't take pictures. Pictures don't turn out very well. Cam scanner that stuff in and submit it as a PDF. All right, thanks.